Today is the second last lesson for our course, and in this lesson I will divide it into two parts. The first part we will try to go through the content on uh, the Unit 5, and then the next part we will go through the content of Unit 6. Unit 5 mainly be related to the bonds. We have mentioned the concept of bonds in Chapter 1, but we seldom explain in detail what does that mean and how do we involve the calculation. So for the first part of the video, we'll go through the concept of bonds first. So actually, what is the bonds? A bond is a long-term contract in which the issuer or the call it bond borrower, usually it will be a bank or some company, promise to pay the bondholders a coupon interest payment. That means, for example, if you have buy a bond of say 10,000 Hong Kong dollars, 10 Hong Kong dollars, perhaps the issuer or we call the borrowers is going to pay you like maybe 100 or $50 per quarter. So that's what we call a coupon interest payment. Remember, when we talk about coupon interest, then it's really the percentage. But if you're mentioning the coupon interest payments, that means in terms of a dollar. Usually periodic, say once per quarter or per half year or per year. And then the principal will not give it to you yet until the last day. We call it the specified days. So that's generally what does bond mean? Similar to the real case, like if you borrow money, if you lend money to the others, then the borrower is going to pay you some cash for a time period, and then at last they will give you back the whole principal. Of course, it's different to mortgage, because for mortgage, actually you try to do a continuous payment from time to time, and at the end, actually you don't have to pay the principal, because actually you have tried to pay the principals from time to time. But if you have time, we can mention it later. But this case, you mainly think about like borrowing money, it will be easier for you to understand. But sometimes in the real case, there is some payment, we call it the zero coupon bonds. Right? Just like, for example, if you are the lender and you are going to lend a money to your friend, say $10,000, and then perhaps after 2 years, they will guarantee that they will give you back like $12,000. Then there's a concept of zero coupon bond, because at the time being they won't give you any coupon, I mean they won't give you any money. They just at the specified days they will give you back the principal plus or what we call the interest. Okay, so actually we are quite interested in how to do the pricing of the bonds, because remember when we consider bonds, that means or made easier. Actually, if you have referred to the video we have done so many times, most of the time for the financial products, they are the contract, and as soon as we made it as a contract, okay, what is the advantage is, first of all, then everything is back and right. Then we can base on the back and right to do to get the payment, to lend the money, whatever else. Secondly, as soon as it's a contract, actually the best way to handle it is if we want to do some adjustment, we can trade it to the others, just like bonds. For example, now you are the lender. Okay, you try to lend money to the others. Maybe you assume that you get you back in 3 years, but perhaps in the first year or the second year, you need to have some money to do some other investment. So that's why you would like to trade this bond at the first year or second year. Then the problem is at that time I try to sell the bonds to the others. So what should be the rational market price? So that is, again, pricing is the main concept for the whole system of the financial mathematics. All right. And bonds can also relate to the interest rate options, but maybe we can go through it later. But first of all, actually, in this unit, okay, in this chapter, we would like to do something called calculate the face value of the bonds at a time period. That means what we should, what is the rational price for us to buy it or sell it. And then to evaluate the financial risk, we always mention about the risk if it is related to derivatives. And then using some computational methods to do the pricing. But be very honest, for the computational part, I may not spend a long time on this particular part because, be very honest, in the examinations, you're not allowed to use Excel or something else. Most of the time, you do it by hand. So I will teach you first how can you do it by hands. For the computational method, I will put it as like a alternative or extra stuff. You may try to go through it by yourself at home if you have time. Okay. So firstly, what you have to understand is the following. There's one called the yield curve. First of all, you understand what yield means. Yield means when the issuer, first of all, try to issue the bonds, what is the price for that particular bonds. Okay, but as you can see in the real market, most of the time, for the yield, okay, is not a continuous data. Because as I said before, when we try to do the pricing of the option in chapter 3 or chapter 4, or chapter 2 and chapter 3, that there are two ways to do the pricing based on the definition of the time. If you try to define the time as what we call a discrete time series, then we do it by like the tree diagram. Assuming it will go ups and downs for a time period and then try to calculate the expected value. And if we assume that time is a continuous case, then that means we can use some calculus method, try to do the differentiation. And of course, because for options, it won't only affect by time, it won't affect by the stock price, interest rate, and so on. It's multivariate, so we can do it by something called a partial differential equations. So in the market, some of them consider as a dividend, some consider as continuous. Both have some advantage and disadvantage. But here, the problem is for yield rate, right? Because if you look at the market, actually, for example, the biggest bond issuer in the world is United States. They're always issuing the US bonds for the other countries or other investors to buy. And most of the time, they will issue the bonds like 1 year, 3 years, 5 years, 10 years, and maximum is 30 years so far. Even though now they try to discuss that they should have some bonds for 50 years, but I don't understand who will buy the bonds for 50 years. But perhaps there is some investor who would like to buy it, who knows. But anyway, they define the bonds based on the discrete case, like 1 year, 2 years only. They won't define it at like 1.456 year or 1.2222 years. But of course, for the time being, then it can be 1.5 years, 2.25 years still. But anyway, most of the time we will consider it as discrete case. But if we want to handle it by some calculus method, we would like to make it looks like continuous. What does that mean? For example, in example 1.1, they give us a yield rate 3, 4, 5.5, and 6. And the whole period is 1, 5, 10, and 20. That means if we try to plot it into a diagram, okay, actually it doesn't look like this. It looks like the 1, 2, 3, and 4. Do you know what I mean? This particular table, 1, 2, 3, 4. Then we have the 1, 2, 3, and 4 here. And we just use something called the broken line diagram to link it up all together. So actually, it's not a continuous case. Okay, so it has been mentioned from here also. In principle, the yield curve is built from a discrete set of observed yield points or yield vertices. Okay. like this here, we have 4 points. We just use some broken line to link up together. But if you want to find a continuous curve to link up these 4 points, is it impossible? Actually, it is still possible. What is commonly be used is the following. We will assume that, okay, we can fill it up by a 3 cubic equations. That means the following: y equals to at to the power 3 bt squared ct and then d. We try to assume that the curve will be like this and see if there's any curve that fulfill the criteria for these 4 points. So what should we do? Then we try to do, this one is quite important because most of the time for the homework they will include at least one question related to this part, so be very careful on the concept here. So firstly, they will assume that this particular curve, they will pass through the 1 to 5. That means actually here, they assume there's a curve here like this, pass through 1, 5, 5, 10, and 10, 20. They assume that there are totally 3 different kinds of curve. So you can see that there's something called y1 here, and then y2 here, and then y3 here. Related to, you can assume it's a 3 different cubic functions. I repeat, you assume it's 3 different cubic functions from y1, y2 to y3. All right, and then after that, because it's 3 different curves, but we would like to make them connect together such that it be a continuous curve. So what should we do next is we try to involve the differentiation. And be very careful, okay? Remember, we should differentiate the curve first before we input any values. And as soon as we said that they're connected together, which means, okay, for the first derivative, this value, okay, compared to the y1, so y2 here, they should be the same. So you can see the sentence over here. And also for the second derivative, that means the rate of change both of them should be the same. That's the idea about the continuous function. Excuse me. Okay, and we use the same concept for the connection for the point when the t equals to 10 here. And we assume that, again, the first derivative and second derivative will be the same. So that's why we have here the first derivative, second derivative are the same. Okay, so after we have considered the first derivative and second derivative, then we would like to consider a few more because for the starting point and end point, we assume that the rate of change is zero. I repeat, we assume that the rate of change is zero. So that's why the second derivative for both y1, y3 for the first point, sorry, starting point and end point must be zero. Must be zero. All right. So after the following assumptions, actually we have together 12 equations with a lot of different coefficients. So we can rewrite it as here. Okay? Don't be scared. Actually, if you are familiar with the algebraic method, actually it's a matrix. It's a matrix, okay, with like 12 times 12 square matrix with another vector equals to another vector. That means, in short, A matrix times X vector equals to the B vector. Okay, so let me explain the matrix one by one. This part is related to the first curve for the first two endpoints, 1 to 5. Second curve, the the starting point endpoint from 5 to 10. And the third curve, the starting point 10 and then to 30. 20 is right, so it's 20 here, 10 to 20. And then we handle the first derivative should be equal for the 5 and 10. Second derivative which we equal 5 and 10. Lastly, the starting point, the second derivative has to be 0. Ending point, the second derivative has to be 0. That's why we have totally 12 times 12 matrix here. And of course, if we had to do it by hand, 12 by 12 matrix, it will be extremely difficult. That's why they will assume you to try to solve it by algebraic software, maybe by Excel, maybe by any other algebraic software you like. Then try to get this solution here. Okay. During the homework, they may still ask you to use the Excel to do it by hands. But if in examination they involve this kind of questions, as soon as you write this matrix precisely, that's fine because we don't assume that you can do it by hands. But anyway, after you finish this calculation, you have to know how to write it down in this case because you cut it, remember, you cut it into 3 parts, 1 to 5, 5 to 10, 10 to 20, represented by 3 different curves. But anyway, when you combine them together, actually it's a continuous curve where these 2 points, the first and second derivative will be equal. And for the end point here, starting point, the second derivative will be 0. It's a continuous curve. So that's how we try to plot the U curve. Even though actually for U is not a continuous data, we only have 4 points, but we try to create a curve such that you will pass successful all these 4 points. Okay, so in the next part, they will teach you how to use Excel to do it. You should go through it as you had to practice the homework. They ask you to solve the 3 times 3 matrix first, and then you should know how to do it. Okay, of course by hand you can do it by inverse matrix, but they teach you step by step on how to do it by Excel. And if you have to do the homework for solving the U curve, just like this self-test question 1, question 2, then you better try to go through this part to know how to do it by the Excel.